Back sharing some more of my great compost of knowledge. It's DIY solar again, and in a lot of applications you need to drive a FET. The micros are only 5 volts, and the FET needs at least 10 volts to turn on to a low on resistance. And so there are high-speed drivers out there. A lot of people think they're professional doing that. If you don't need the speed, I'd avoid using them. They can cause more problems than you can imagine. I was helping a guy who went through $200 in FETs and IGBTs trying to get something to work, and it was because of the high-speed driver. So here's what I use. I use these little modules I make. It's a just wire, resistor, and an Opto Isolator, and take a little hot melt glue, stick it all together. This is what it looks like. Nothing fancy, but it makes a very clean circuit. This is what it looks like. We have a 330 ohm resistor with an Opto Isolator, a PC817, and these are the 2 wires coming in and the 2 wires going out. The collector we connect to 12 volts, emitter to a 750 ohm resistor, and that goes to the FET, and that's fine enough. It's not high speed. I don't do anything fast. I do it half fast. So the one thing you got to look out for is the Opto isolators have a gain to them, and not like a transistor that has 60 or 300. They call it a transfer ratio, and this is a PC817. Up in the corner you'll see a letter or no letter. If it's none, it can be anywhere from 30 to 600%. So if you're putting 10 mA through, you could get, with this particular one right now, I've set it on 12 volts and I got these resistors shown, and I'm getting 10.57 volts out. That's into a 500 ohm resistor, so that comes out to around 210%. So this one is in spec. It's a C, and that's a quick way to test. But as you can see, anything less than a C, it may not work. You may not get enough drive. So this is the simple test setup. Got 12 volts. I use a 100 ohm resistor to calibrate it. 1 volt across that will be 10 mA, and it's about 750 ohms, something in that range, in addition to the lower resistor to get that 10 mA. And then 2,000 ohm resistors in parallel, that gets you 500 ohms. It's a nice even number. Hard to get a 500 ohm resistor without paralleling them. And whatever that voltage comes out, you multiply it by 2, and that's the equivalent of mA, or the gain of the system. So that's what I wanted to show you. These things, I mean, I buy them 300 at a time. They're cheap. They're only about 10 cents each, and this is a quick, easy way to drive your loads. Now, if you're using something like a Nano or a Uno, there's some code that'll allow you to drop the hertz ratio of the PWM down to 120 hertz or 240 hertz. That code is in the description. So no reason to go high speed. I actually have one of these that I use a 300K resistor on. I used it for a while, and I just had a 9-volt battery driving it. I mean, the current was so low, it made a quick, easy, high-side driver for something you just would turn on, stay on. You're dealing in microamps of use, so the battery would last basically its shelf life. So you don't have to go expensive. You can go the easy way. And it's a quick, easy build. You know, solder it together, put some hot melt glue there, and then put it in some heat shrink tubing, and you have a nearly indestructible waterproof driver. Keep these leads that go to the FET as short as possible. You don't want to pick up noise. That's it. Thanks for watching.